Now, two rules. This second section is much more straightforward than the first section. There's only two rules. When you finish the problem, other than being in simplest form, you may not have a fraction inside the radical sign. All right? As well, you may not have a radical sign in the denominator. Okay? Some of our problems will be like walking in the park. It's very straightforward. Some will be like riding a bike. There's a little bit of a trick to it. Some is like driving a car. You can go fast, but there's a lot of little steps to take care of. Let me show you some simple examples at the forefront. First thing you do is just look at the bottom and say, hey, can I take the square root of it? So look at the 9. Can you take the square root of 9? Yep. What is it? 3. Can you take the square root of 144? 12. Now examine your answer. Is it simplified? What's 12 over 3? 4. So whenever we get an answer, we always try to reduce. Second one. Can we take the square root of the bottom? What's the square root of y squared? Y. Now the top's a little bit more complicated. Let's break down the top. 5, x squared, and x. Why did I break the x cubed up into an x squared and x? Because that's even, and that's the leftover. That's a pair all by itself. So what does the 5 and the 5 come out as? Okay, that comes out as a 5. What does the x squared come out as? X. Is there anything left in the top? Square root of x. What about that y? Does anything cancel? Always when you finish, look to cancel. Does anything cancel? Not in this case. All right, let's look at the third one. 49. Does that take a square root? 7. What about x to the 6th? Times x cubed. Good. So the nice thing is the denominator got taken care of. We'd have to deal with the top. Help me with 72. I heard 8 times 9. So I'm going to put the 9 first. Okay, so that's 3, 7x cubed. But you know what I see about that 8? I feel like the 8 can go further. Isn't the 8 2, 2, and 2? Is there a pair there? Okay. So those two square roots of 2's come out as 1, 2, and so 3 times 2 is 6. And don't forget the last root 2 at the back. So these two 2's come out as a 2. 2 times 3 is 6. That root 2 comes here. Now we say, does anything cancel? Not in this case. So each of these three problems pose a different scenario. This last one had some variables. This one had variables in the top. So different scenarios for different problems. I'm trying to show you all the possibilities. What did you notice happen on each of these three, though? What did the denominators all do? Yeah, they're all perfect squares. Sometimes that's going to happen. How often? Not that often. But it might. So when it does, look for it. Let's look at part 2. It says simplifying radicals with fractions that can be simplified first. That might be beneficial to us. Does anything simplify between 54 and 2? What does 54 divided by 2 equal? Can you do that in your head? 27. If I can get rid of the denominator that quickly, my life is a lot easier. Okay? Now all I have to do is simplify the top. Who can break down 27 for me? 3 and 9. Do I need to break down the 9 any further? It's already a perfect square. So let's save ourselves some time. What's the square root of 9? 3. Yeah, it's a pair all by itself. So your answer is 3 root 3. So sometimes you don't want to continue, Elliot, to break things down. If you see a perfect square, stop with that part and just pull it out. All right, so that's a possibility. Look at the next one. Does anything cancel? Yes. All right, the x's cancel to what?
x squared. And what about the 8 and the 2? They're 4. So here's our problem. 4x squared. What's the square root of 4? 2. Square root of x squared? X. Boom. So canceling in this case made it a lot easier. We happen to be left with something that was very straightforward. Now, number 6 is kind of unique. The 18 and the 9, I don't think any of you have a problem with. That's 2. But the x's, where are they larger? On the bottom. So we're going to have x to the 4th on the bottom left over. I can't take the square root of 2. Can I take the square root of x to the 4th, though? Yeah. Remember what we do? We cut it in half. So my answer is going to look like this. Root 2, when I say root, that means square root, over x squared. Just like so. Now, all of these, this was case 1, case 2. Let's look at case 3. I actually put some notes at the top of this one because I thought it would be helpful. When you don't have a perfect square in the bottom, this is what you do. You do something called rationalize the denominator. Rationalizing the denominator means, basically, it's a big fancy word for making the bottom a perfect square. Remember on the first page, they were all perfect squares. Look at this one. Is 5 a perfect square? No. If it's not a perfect square, I want to make it a perfect square. So think with me. 5 times what is a perfect square? Yeah, 5 times 5. So let's take this problem and let's multiply by root 5 on the bottom. If I multiply the bottom by root 5, to be fair, Dylan, I must also multiply the top by root 5. So what's in my parentheses right now? What's root 5 divided by root 5? Can you multiply by 1? Yeah. Now, here's the reason why I did that. My denominator now is root 25. My top is 2 root 5. Can you take the square root of 25? Yeah. That's 5. So you get 2 root 5 over 5. Your goal, once again, Vicki, is to get the square roots out of the bottom. If the square root's not on the bottom, you compute it. That's your goal. All right, look at the second one. Root 7 over root 8n. The bottom is definitely not a perfect square. Let me give you a little hint. I would love the bottom to be 16n squared. 8 times what is 16? 2. N times what is n squared? N. Why do I want 16n squared on the bottom? That's a perfect square. And it's a small one. My top, what is 7 and 2n? What does that become? Root 14n. So, now can we solve it? Someone tell me what's the square root of the bottom? 4n, and the top stays the same. Now I look and I ask the same question I did on the first page. Can you cancel anything?
How do
Before
you
you
make, like, how do you, with like terms, 7 and 2n are like terms?
Since they're both under the radical, you can multiply them together. You can only cancel if both things are outside or both things are inside. The 4 is outside, the 14 is inside. So do they cancel? No. But if the 14 had been outside, you could have. All right, let's look at our next one. I would love to have the square root of what, would you think? 100. How do I make this 10 into 100? Multiply by 10. What's my numerator? 70x. Max, and this is your question from before. The 7x times 10. Okay? So that 70x stays on the top, and the bottom just becomes what? 10. In each case, is the denominator no square root, right? So that satisfies it. Let's see if we can figure out 10, 11, and 12. Each one poses a different problem. 10. Give me your thoughts. What would you like the bottom to be? I'd like it to be 4, okay? So let's make it a 4. To make that a 4, what must I multiply by? Yeah, I must multiply by a 2. Now be careful. What does the top become? Be careful here. There's two options. Does it become square root of 6, or does it become 3 root 2? It becomes 3 root 2, because this is the first one where the number on the top was and also in the square root. Can I leave my answer like this? Why not? Yeah, there's a square root in the bottom, so you can't leave it like that. But we sure can take that and take it out as a 2. Oh, and I have 2 2's in there. Should I cancel these?
No.
Why not?
There's 2's inside.
One's inside, one's outside. Don't do it. So that is your answer. Boom. But beware, if that had been 3 and 6, would it cancel? Then it would have. 12x. What would you like to have in the bottom? 36x squared. That is a perfect square. I like that. Someone besides Jonathan, he gave us the idea. Someone tell me how to get there. How do you go from 12x to 36x squared? Jesse? Multiply by 3x. Good. Jesse, can you keep going and tell me what the new top would be? I'm looking for what's 4 times net square root of 3x. Good. 4 root 3x. All right, now the bottom. Back to the bottom here. Square root of 36? Square root of x squared? And the top, 4 root 3x. Does anything cancel?
Oh, 3 and the 6.
The 3 and the 6 don't, but the 4 and the 6 do. You had the right idea, Max. The 4 and the 6 both cancel, Elliot, because they're both outside. So 4 and 6 cancel to 2 and 3, and everything else stays the same. Little things on different problems. Look at 12. Okay, Jonathan's done a lot. Jesse's done a lot. Jake's done a lot. Someone else. What would you like that denominator to be? 36. Yeah, I'd like it to be 36. So let's make it a 36. Matt, what do you have to multiply by to make that 36?
6.
Another 6. All right? Nate?
30.
What's the top going to be?
30y.
Good. 30y. All right, so 30y over
36.
square root of that is?
6.
Good. Now we ask ourselves about canceling. Why do you say no, Jess? One's in, one's out. Tiff, question.
Wait, I'm confused on why that one is 30y and the other one is 4 square root of 3x.
Okay. Let me see if I can answer this clearly. This 4 is outside the radical sign, and that's inside. So you can't combine those. This is both are inside. Let's come back to here. Look at 10. See the 3 and the 2? They're both outside. But look up here. You see the 7 and the 2n? They both ended up inside. Does that help? So only combine the things outside or combine the things inside. Don't mix the two. Does that make sense? Other questions? Blow this out so you can see all the different parts. Other questions?